My name is Lorena Camargo-Ayala, and today I am going to tell you a little bit about our research work that we have entitled Rational Design, Synthesis, and Evaluation in Silico of Homologous Local Anesthetic Compounds, such as TASK-1 and Kv1 channels blockers. Introduction. Atrial fibrillation is the most common type of arrhythmia and is a risk factor for increased strokes, heart failure, and cardiovascular morbidity, with effects that in many cases becomes disabling or cause death, generating a significant impact at the socioeconomic level. In patients with atrial fibrillation, it has been observed that the duration of the actual potential change decreases its duration. This has been attributed to the occurrence of atrial remodeling. The depolarization of the membrane initiates the action potential of the cardiomyocyte by the entry of sodium ions through the NaV 1.5 channels. The next action potential stages are the repolarization currents carried out by different potassium channels, such as Kv1.5 channels and TASK-1. Kv1.5 outflow rectifier channels are highly expressed in human atria, but not in ventricles, and are primarily responsible for the ultra-fast potassium outflow current I-core, regulating repolarization, thus becoming a pharmacological target of atrial antiarrhythmic drug, since they see the atrial action potential increase the duration and prolong the refractory period without having effects on ventricular repolarization. On the other hand, the background currents of TASK-1 channels have acquired great relevance as therapeutic target for treatment of atrial fibrillation because they have been reported to regulate the duration of the action potential. Therefore, Kv1.5 and TASK-1 blockers could become innovative strategies against the atrial fibrillation, following the paradigm of polypharmacology, that is the modulation of multiple receptors by single ligament. The development of different bioinformative tools has allowed the design of drugs in a rational way. Using defined therapeutic target, thus we can establish most favorable characteristics a lead to interact with a receptor from computational simulation. This information allows us to design and synthesize new compounds with precision. In this context, the main objective of this study is based on the common characteristic of local anesthetics to propose the synthesis of new analogs of local anesthetics and to evaluate them in silico as TASK-1 and Kv1.5 channel blockers. To develop this work, the methodology that we have proposed is the following. First, we proposed a pharmacophore for local anesthetic compound, establishing the most important characteristics in order to propose a new series of compounds, which were finally evaluated through molecular docking simulations. In Figure 1, we could see the proposed pharmacophore. In green, we could see the hydrophobic domain. In orange, the aromatic ring. In light blue, the hydrogen donor group. In red, the hydrogen acceptor. And in blue, the cationic domain. That is the typical local anesthetic drug that has the hydrophilic tertiary amine domain and intermediate linker. N-amine or ester group, and a hydrophobic aromatic ring domain. A series of compounds were proposed and were obtained through reaction in two steps. For in silico analysis, docking IFD was used. Those molecular couplings simultaneously were performed, establishing the most stable ligand-receptor interaction, where I knew the neutral and protonated states of each ligands were considered and 10 poses were generated for each molecule. The binding free energy was calculated with the MMGBSA method, and the poses were organized according to the best free energy. As seen in Table 1, a score was made by adding the position of each conformer in the table. That was common between TASK-1 and Kv1.5 channels. If the sum between the two conformers is small, this molecule binds more favorably to the two channels. The molecules with the most favorable binding energies in common between the two channels are shown in order in Table 2. Figure 2 shows the poses with the best GBSA energy for the 5 common compounds in the two channels selected. The binding sites of these compounds in Task 1 is between the pore and the fenestration in Kv1.5. The ligand interacts with the residues of the side pockets. In conclusion to a rational design, the synthesis and characterization NRL2 and the substituted acetamide compounds based on a proposed pharmacophore or local anesthetic was carried out, which turned out to be interesting inhibitors simultaneous TASK-1 and Kv1.5, which makes them compounds with potential polypharmacological interest for the treatment of atrial fibrillation. Finally, we want to say thank you